This slideshow highlights the wood pellet boiler system in the Mason Elementary School in Mason, New Hampshire. This presentation is meant to educate regarding alternative energy systems. The school building was refurbished and expanded in the 2009 timeframe. It was built incorporating the latest environmental and energy standards. This is an aerial view showing the quadrangle shape of the building with an inner courtyard. The heating system is at middle left. The cafeteria and gymnasium are on the right. It occupies approximately 20,000 square feet. A Massachusetts company designed and installed the pellet boiler system. This photo shows the external storage hopper adjacent to the boiler room. The hopper holds 5 tons of wood pellets, which typically last for several weeks in cold weather. A flexible auger feeds pellets to the furnace room. An internal hopper is kept full by min and max sensors controlling the auger motor above it. The low-level sensor is on the opposite side of the hopper. There is also a temperature sensor to set off alarms should a fire occur in the hopper. This is an overall view of the burner system. The hopper is behind the gray control panel. This is another view of the boiler room. Pellet release is controlled by 2 augers. One pulls pellets from the hopper, the other feeds pellets into the burner. The blue squirrel cage fan adds air for combustion and maintains a positive pressure in the burner. The airflow also keeps the pellet ash knocked down and prevents flame from coming back up into the hopper. Note the gray jacketed electrical cabling. Everything is automatically controlled. This is a close-up of the pellet feed system. The feed rate is set manually and turned on and off automatically by the control system. The combustion chamber is at the bottom. Note the coarse ashes. These are removed every 2 to 3 weeks, which is generally 1 5-ton hopper load. The burner is shut down for this. Cleaning the combustion chamber is very labor intensive, but is necessary to keep it running optimally. The fine ash is self-removed and ends up in this box, but this only occurs if the coarse ash builds up from not being removed. The fine ash box is removable to dump its contents. The auger motor runs on a time sequence when it's set to be in the automatic mode. Note the red solenoid interlock. It must be in place for the ash motor to operate. The exhaust gases flow through one set of open tubes, visible at top, and out the other set to the exhaust. The water jacket surrounds the top of the boiler. Note the oversized exhaust flue. This is necessary to minimize any back pressure. The exhaust gases need sufficient push to get through the heat exchanger tubes. Note the silver insulated box under the exhaust stack that traps any fine dust before it exhausts. The hot water exits at left. It returns at right. Note the 2 overpressure valves. There are 2 thermostats for the water jacket, an operating temperature and a high temperature cutoff. There is also a low water cutoff monitor. There is an industrial-sized expansion tank that acts as a shock absorber to maintain constant pressure whether the boiler is on or off. It prevents relief valve release of hot water and prevents air pockets from forming if the water pressure falls too low. The domestic hot water tank holds 120 gallons, which is also heated by the boiler system. This control panel automatically runs the boiler. The indicator lights show status of its components. This is a close-up of some of the many control lights of the control panel. There are pumps and piping everywhere. Literally almost everywhere. Red pumps move water within the boiler room. Green and blue pumps move hot water for heating. Gold pumps move domestic cold and hot water. These are shutoffs and controls for all the pump motors. This is a repeat of the aerial view of the school, just to show that there are long distances to move the heating water. There is baseboard heat in all the rooms. There's also forced hot air in all the rooms. The air handlers for this are in the attic spaces. Each room has an energy recovery ventilation system, or ERV, that preheats incoming outside air by the exhausted inside air. If additional heating is needed, the radiator in the supply air duct is heated by the boiler system. This air transfer assists in ventilation and controlling humidity. Air transfer is disabled in very cold weather. This is a diagram of how an ERV operates. Stale inside air is moved through the exchanger and exhausts to the outside. It preheats incoming outside air, which supplies warmed, fresh air to the building. Not shown is a hot water radiator that also heats the incoming air in colder weather. This heat exchange is disabled by the main computer if outside temperatures are too cold for this to operate efficiently and to prevent frozen pipes. The school is a duplicate boiler which runs on fuel oil. It can be used as a primary or secondary heat source depending on fuel costs versus pellet costs. In very cold weather, both may be on simultaneously. This is a view of the fuel oil burner system. These are the fuel oil tanks. When they get filled and used depends on market prices. The primary and secondary sources of heat can be switched between the wood pellet or the fuel oil boilers. The backup heat source will come on when the primary can't keep up in severe cold weather. This is the computer controller circuitry, which is behind the just previously shown control panel. This computer maintains the heat, air intakes, and hot water for the entire school. It also overrides the heating parameters and opens all heating solenoid valves in the school to prevent freezing. There is a backup diesel generator for power outages. Unfortunately, however, any electrical power blink requires a manual restart of the pellet boiler. Otherwise, it will go into a shutdown mode. The diesel fuel is stored in an internal tank below the generator. For additional alternative energy tours of houses in Mason, New Hampshire, go to masonnewhampshireenergy.org.